Have you ever stopped to think about how your digital world actually works? I mean, really works. In this explainer, we're going to pull back the curtain and go on a journey. We'll start with the tiniest piece of data and build our way all the way up to the cloud, uncovering just how your computer stores, well, everything.
All right, so here's our game plan. We're going to start with the basics, what I like to call the digital alphabet. Then we'll look at the computer's short-term memory, its active brain, if you will. From there, we'll explore its long-term library. We'll also trace the incredible evolution of storage and then wrap it all up by talking about why any of this actually matters to you.
So, first up, the digital alphabet. And you might find this hard to believe, but every single thing you see on your screen, the words, the pictures, this whole presentation, it's all built using a language that has only 2 letters. Yep, just 2. So that brings up a really fundamental question, right? When you strip everything else away, what is a single digital thought actually made of? What's the most basic building block?
And the answer is a bit. This is it, the absolute ground floor of all data. It's just a simple choice, on or off, a 1 or a 0. You can think of it like a light switch. Every single complex thing your computer does is really just billions of these tiny switches flipping on and off at mind-boggling speeds.
Now, a single bit by itself isn't all that useful. But when you group 8 of them together, you get something really special, a byte. And a byte is powerful enough to represent one single character, like the letter A or the number 5.
So you can see the scale here, and this is the crucial part. A bit is just the switch, but a byte? That's the first building block we can actually recognize as real information. It's the difference between a single on-off signal and a complete readable character. Okay, but how does a computer know that a specific combination of ones and zeros, say 01000001, actually means the letter A? Well, it uses a translator, a character code, like ASCII. Just think of ASCII as a universal dictionary. It's the rulebook that says, hey, this pattern of 8 bits means this letter, and that pattern means that number. It's the key that turns raw code into the language we all understand.
All right, so now that we have our digital alphabet, where does the computer do its thinking? Let's dive into the computer's short-term memory, or what we call primary memory. This is the super fast workspace where all the magic happens. Now, there are 2 main flavors of this memory, RAM and ROM. RAM is kind of like your computer's workbench. It holds all the apps and files you're actively working on so you can get to them in a flash. But, and this is a big but, it's volatile. The second you turn the power off, that workbench is wiped completely clean. Poof, gone. ROM, on the other hand, is non-volatile. It holds the permanent, unchangeable instructions your computer needs just to boot up. It's like the little instruction manual that's baked right in. So if RAM is just a temporary workbench, where do you put your files when you're done working on them? Well, that's where secondary storage comes in. This is your computer's long-term digital library. It's where all your files get to live, permanently.
And this table really lays out the essential trade-off. Primary memory, like RAM, is wicked fast, but it's expensive, and you don't get a whole lot of it. Plus, it's volatile, right? It forgets. Secondary storage, like your hard drive, is a bit slower, but it gives you massive amounts of space for a much lower price. And, most importantly, it's non-volatile, so it remembers everything, even after you shut down.
The way we store all this data permanently has changed so much, it's pretty incredible. It's a really fascinating story that takes us from these big, clunky machines with moving parts all the way to the cloud, which feels almost invisible. And this timeline just shows that amazing evolution. We started with mechanical hard drives, then we moved to things like CDs and DVDs. The next huge leap was solid-state storage, silent, no moving parts. And now, so much of our stuff just lives in the cloud. With every single one of these steps, the amount of stuff we can store has just exploded, while the cost has totally plummeted.
For decades, the hard disk drive, the HDD, was the absolute heart of every personal computer. I mean, it's a mechanical marvel. It uses a super-fast spinning magnetic disk and this tiny little head that zips back and forth to store and find your data. It was the original workhorse.
But then came solid-state storage, and oh man, was it a game changer. With absolutely no moving parts, devices like SSDs and those little USB flash drives are just ridiculously faster, tougher, and way smaller. This is the tech that makes our modern laptops and phones feel so snappy and instant.
And that brings us right up to today with the cloud. With cloud storage, you don't even have to think about the physical device anymore.
Your data is stored on these massive, super powerful servers in data centers all over the world, and you can get to it from pretty much anywhere you have an internet connection.
So we've covered a ton of ground, right? From simple bits and bytes all the way to this giant global cloud. But let's take a step back and ask the big question. Why is this permanent secondary storage so fundamental? Why does it matter so much?
Well, when it comes right down to it, secondary storage is the foundation of our entire digital lives. Because it's non-volatile, we don't lose all our work when we shut down. It gives us massive, affordable space for all our photos, videos, and documents. And maybe most importantly, it lets us make backups to keep our data safe and easily move it between our devices. It literally provides the permanence our digital world is built on. So, we've seen how our digital world is built up in these incredible layers, from a simple on or off switch, a single bit, all the way to a file that lives on a global network of computers. It's been an incredible journey of innovation. And that leaves us with one last big thought. What's next? What will the next layer of this digital revolution even look like?